Welcome to the statistics class. What we're going to study today is measured up position. We will explain how measured up positions such as quartile and z-score help us understand the distribution and variation of data. You will learn how to compute and interpret the 5-number summary and the interquartile range and use them to describe how data are spread out. You will also interpret box and whisker plot, which gives us a visual summary of data. Finally, you will learn how to calculate, interpret, z-scores to determine how a value compared to mean and how unusual it might be. Let's get started today's lecture. Why measuring spread matters? Two classes took the exactly same quiz, class A, class B. I give 5 scores for each class. So what is mean of each class? So this class A, class B, exactly same mean is 80. Next question is, which class shows more variation in score? So class A, minimum is 78, maximum is 82. Class B, minimum is 60, highest score is 100. So you're going to say class A, only 4 point different between lowest, highest. Class B, largest different, 60, 100, that's the 40 different. So even though means are same, which class performed more consistently? As you see, class A is more consistent, but class A has great variation. That's we're gonna measure spread. Measuring spread helps us understand how much data values vary, not just where the center is. Two data sets can have the same mean or same median, but very different in how spread out they are. That's why measuring spread is so important. Then by measuring spread, we can see how consistent or variable the data are. Second is identify unusual values we call outliers. Third one is you can make a better comparison between the two different data sets, even though the mean are the same. Let's talk about quartile. What are they? So what is a quartile? Quartile is approximate divide all the data set into the 4 equal parts. So we have data set, we divide all the data set into the 4 different parts. So first one is the first quartile, second quartile, third quartile, then we have 4 part of data set evenly, okay? Quartile help describe the spread, not just the center, guys. So how gonna find the quartile? I'm gonna discuss here. First example, let's find the first, second, third quartile. So this data set tells us amount of fuel the automobile commuters waste due to traffic congestion in the 15 largest U.S. urban areas where the population are more than 3 million are reached. That's gonna be amount of fuel. I just put in the order. Now, we're gonna divide this data set into the 4 parts evenly. That's what we're gonna do it. First, we want to find the middle. Middle is gonna be median. You remember median divide the data set into the 2 halves. So what is total? Total is 15. Number of data is odd. So we can find the middle. So let's count it. 1, 2, 3, 4, 5, 6, 7. That's right. That's the one thing. 1, 2, 3, 4, 5, 6, 7. That's another 7. So you find the quadrant, second quadrant, that's the median right here. That's the odd number. Middle is Q2. So we have this one is a 7. The other is a 7. You have to separate evenly into the two parts. Do you understand that? Now, let's do the first part. First is 1, 2, 3, 4, 5, 6, 7. Then we're going to make this into the two part. So that's the odd number. You're going to find middle. That's going to be here 26 because that's the 3. This is 3. You divide same 3 evenly. So this one is Q1. That's the first quartile. Then we're going to do second half. Also, this is data set is 7. You are looking for the middle because that's the odd number. 7. So 1, 2, 3. 1, 2, 3. Middle gonna be 35 here. So that's gonna be third quartile. So right now, we find the first quartile, second quartile, third quartile. One more time, guys. Second quartile is median. That's the 1/2, second half. Here is the first quartile. You divide the first half evenly. 3, 3. Q3, second half divided by evenly. Okay? So let's see here. Here is just 3 data values. So it's about 1/4 of large urban areas. Auto commuters waste 26 gallons of the fuel or less. That's 1/4. Another way, 25% of large urban areas, the auto commuters waste 26 gallons of fuel or less. Okay? Another one. This one is first half. So what are you going to say? About 1/2 waste 31. That's the median. Gallons or less. That's the first half. Okay? This one is going to be what? That's going to be about 3/4 waste 35 gallons or less. Okay? This one is 1/4. This one is half. This one is 3/4. This one is 1/4, right, guys? So 1/4, this one is another one, then waste more than 35. That's you're gonna have conclusion. We study quartiles, right, guys? Now I give 5 number summary here, guys. 5 number summary describes how a data set is spread out by identifying 5 key values. First one is median, that's the smallest data value. Second is the first quartile, the value below which 25% of data fall. Second quartile, that's the median, middle value of data. Third quartile, the value below which 75% of data fall. Maximum is the last data value. So 5 number summary gonna be give 5 number. Medium, minimum, first quartile, median, third quartile, and maximum. That's what we call 5 number summary. Why this 5 number summary is useful, guys, here. Helps summarize the center and spread of data set. Okay, so also make it easier to compare distribution. That's a 5 summary, very helpful. Third, provide the foundation for creating box and whisker plot visualization. That's 5 number summary help us visualize the data set. Now let's find the 5-number summary. Here is a test score on the first exam in the statistics course for 10 students. So here is a data set, guys. The lowest 55, largest 97. We're gonna find the 5-number. Minimum, Q1, Q2, Q3, maximum. Let's find the minimum first. I'm gonna put the data in order. If you not, data doesn't show in order, you're gonna do first. Put all the data value in order. That's much easier to find the 5-number, okay? First one is minimum. What is minimum? That's the lowest score. That's gonna be 55. That's right, at 55. What is gonna be maximum, guys? Maximum is 97. That's I put the maximum. Now, we're gonna find the Q2. Let's check the how many data entries. 10, even. Then you're gonna find the 2 data value in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So middle is 85, 83, 85. So how gonna find the median Q2? Average of 83, 85, right? So 83 plus 85 divided by 2, that's gonna be 84. So you're gonna put the median in the here between the 83, 85. That's gonna be median. Now, after you find the median, guys, how did you find the median? So 83, average of 83, 85, right, guys? Now, that's the median. You're gonna split this data set into the 2 parts. First part has 5 data set. Second half also 5 data set. Then you see the first half. Find the median here. 1, 2, 3, 4, 5. That's the odd number. Can you find the middle? Middle is 75, right? That's gonna be first quartile. Guys, make sense? Now, third quartile, second half. 1, 2, 3, 4, 5. What is middle? 93. That's the third quartile. So now you find all the 5 numbers. Medium, first quartile, second quartile, third quartile, and maximum. Now, we're going to create box-whisker plot. Another way to call box plot. Here is box-whisker plot. Looks like this. So, what is a box-whisker plot is? Graphical display that summarize your data set using 5-number summary. Look at this. Here, first one is you put the Q1 and Q3 and make a box. Okay? Then second is you put the line in the median. That's the Q2. That's the box. Then what you have to do, you extend the line from the box out to the median, out to the maximum. Then this box-whisker plot help us to see where is the center, how then spread out, and potential outlier of data. Okay, now we're gonna sketch the box and whisker plot with 5-number summary now. So how gonna create the box and whisker plot? Here is a 5-number summary. I give the number line. So first one is you start Q1 47. You have Q3 58.5, draw the box. Okay? Then you find the median Q2 55, 55. You draw the line. That's the median. Then find the median 19 plot the point, maximum 61, plot the point, draw the line between maximum and minimum. Then you're gonna put the point here, 47, 55, 58.5. That's how to sketch a box and whisker plot by using 5-number summary. Let's interpret this meaning, guys. Look at this one. We have a minimum, you have a maximum, you have a median, first quartile, third quartile. Based on this box whisker plot, we have a couple of interpretation. Each whisker represents about 1/4, 25% of data. From here to here, 25% data set, here to here, 25, here to here, 25, here to here, 25. That's you have to remember that. That's the 25 I talk about. Here is left whisker shows about 25% of data values are less than 47. Do you understand that? Next one is gonna be here. That's 25 also. What are you gonna say then? That's the 25. Right whisker indicate about 25% of data values greater than 58.5. Then box is middle. That represent 50% of data set. So we're gonna say here, guys, the box represent about half of data, which is between 47 and 58.5. That's you understand how to interpret the box and whisker plot, okay? So another thing you noticed, this line is longer compared to this one, right? Box is right there. Minimum is here. Maximum is here. So what are you going to interpret to this one, guys? Left side is longer than right side. We're going to say length of left whisker is much longer than right one. This indicates data gonna be data set has positive outlier to the left. Also, this one is skewed left because left side has longer tail. That you understand this box and whisker plot. Let's create a box and whisker plot for this first exam score. We already find 5-number summary. So how gonna create a box whisker plot for this? First start with 75. First quartile, 75. Next one is Q3, 93. Then draw the box between the two values. Let's draw the box. Then you're gonna use median. Median is 84. Draw the line. Then we see minimum 55. Maximum is 97. Draw the line. That's you create a box and whisker plot. Let's investigate this box whisker plot. Couple of things. Box, how many data between the 75 and 93? That's gonna be 50%. How many data below the 75? 25%. Guys, okay? How many percent of data greater than 93, 97? That's the 25%. That's how do you understand this box and whisker plot. Another thing, left is longer than right side. This distribution might be skewed left distribution. So now I'm gonna define interquartile range first before we talking about potential outlier. What is interquartile range? Interquartile range measure spread of the middle 50% of data. Previous slides I showed the 50% of data is from Q1 to Q3, right? So IQR in a quartile range is gonna be Q3 minus Q1. So IQR in a quartile range describes the spread of central values and identifies potential outlier. we're going to use IQR to find the potential outlier. Then what is outlier? Outlier going to be values that are far below the Q1 or far above the Q3. I'm going to show how I'm going to find outlier by using IQR. How going to identify outlier? Outlier is data value is unusually small or unusually large. Here is how to calculate outlier, guys. Outlier rules, IQR method, you have to find row bound, guys. Q1, first quartile, minus 1.5 times IQR. IQR is inner quartile range. How gonna calculate? Q3 minus Q1. Then you're gonna have another one, upper bound, third quartile plus 1.5 times IQR. This one is row bound. You're gonna calculate. This is upper bound. You're gonna calculate. That's we're gonna say outrider rule. You calculate low bound, upper bound. Then any data value below the low bound or above the upper bound is gonna be outlier. That's where you're gonna find outlier, guys. I'm gonna give the example, but before that, you're gonna thinking about outlier rule. You're gonna calculate IQR first, then you're gonna find the low bound, upper bound, then look for the data below the low bound, above the low upper bound. That's gonna be outlier. Here is tuition cost for 25 liberal arts colleges at least. So find the IQR and are there any outliers? So here is data set. I already find median, first quartile, third quartile, okay? So we want to find IQR and outlier. So how gonna find the IQR? Inner quartile range gonna be Q3 minus Q1. That's you're gonna find it. Inner quartile range is Q3 minus Q1. Q3 gonna be 58.5 minus 47. That's gonna be 11.5. That's the inner quartile range. After you finding inner quartile range, we're gonna find low bound. Low bound gonna be Q1, first quartile minus 1.5 times IQR. Q1 is 47 minus 1.5 times inner quartile 11.5. This one first, guys, okay? You're gonna have 47 minus 17.25 because multiplication first. Then you find the low bound is 29.75. You find the low bound, now you need to find the upper bound. Upper bound gonna be Q3 plus third quartile plus 1.5 times IQR. Q3 gonna be 58.5 plus 1.5 times 11.5. That's gonna be, you're gonna, this one first, I said, 58 plus 17.25, that's gonna be 75.75. Now, you find the low bound, you find the upper bound, go back to the data set. So here is data set, low bound 29.75. Find data value less than 29.75. You only find 19. That's gonna be outlier. Okay, guys, everything makes sense? Upper bound 75%, 75. Maximum is just 61. There is no data value greater than 75% to 75. So you have only find one outlier. That's gonna be 19. Let's explain one more time, guys. Here is gonna be, guys, you have this data set. Find the IQR, Q3 minus Q1. Then you find the low bound, upper bound. Look for the data value. there is data value less than low bound. There is data value greater than upper bound. If there is, that's the outlier. Here is another example. We're gonna find outlier, okay? If you wanna find outlier, we need to find IQR first. IQR gonna be Q3, third quartile minus first quartile. So here is a median. That's the first half. Then here, 3 data value. We're gonna find the first quartile. That's the middle. That's the Q1. Q1 gonna be 2, 3, 5. Second half, also 3 data value. We have find the middle. That's gonna be Q3, 285. Now, can you calculate IQR? Interquartile range. That's gonna be Q3 minus Q1. Q3 gonna be 285. Q1 gonna be 235. That's gonna be, we have to do it, right guys? 285 minus 235, that's the 50. Then we're gonna calculate low bound. We need to find upper bound. So Q1 is 235. 235 minus 1.5 50. I say this one is first. So 235 minus 1.5 50. That's gonna be 160. What is upper bound? Q3, 285 plus 1.550. Make sure this one first, guys. That's the 7 point, I think it's 775. The meaning is 360, okay? So you find the low bound, you find upper bound. Can you see it? 160 low bound, 360 upper bound. Go back to data here, guys. There is no data value less than 160. There is no data value gonna be greater than 360. There is no outlier. This one is no outlier. We studied 5 number summary and a box and whisker plot to find the position of data. Now I'm gonna introduce new way to find the position. That is gonna be G-score or standard score. What is a G-score? G-score tells us how far a value is from the mean. Second is measured in standard deviation. So how gonna interpret? Z value is 0, value is exactly at the mean. Z value is positive, the value is above the mean. Z value is negative, the value is below the mean. So G-score tells us how far a value is from mean. Here is visualization. That's the number line with the Z-score. Here is Z equals 0. That's gonna be mean. G equal positive this side. We're gonna say value is above the mean. G is negative. Value is below the mean. Also, Z value is between negative 2 and 2. That's a usual score. Z value is negative 3 and negative 2 or 2 and 3. We're gonna say unusual score. Less than negative 3, greater than 3, we say very unusual score. Then how gonna calculate the score with mean and standard deviation? That's we're gonna do next slide. Now, how gonna calculate the Z-score or standard score? If X is observation from the distribution with the mean, mu, standard deviation is sigma, standard value of X gonna be here. Z equal X, that's observation value, minus mu, mean divided by sigma. We call this one is Z-score or standard score. Let's have first example. Let's have example to find the Z-score. So the mean speed of vehicle along a stretch of highway is 56 miles per hour. with a standard deviation of 4 miles per hour. You measure the speeds of 3 cars traveling along this stretch of highway as 62 miles per hour, 47 miles per hour, and 56 miles per hour. Find the z-score that corresponds to each speed. So this one is, we gonna using this one, z-score gonna be x minus mu over sigma. So you need to find the mu. That's mean you need the standard deviation. You're gonna find the mu and standard deviation. Mu is mean and standard deviation from the equation. So where is the mean? Right here. Mean speed is 56. That's mu gonna be 56. Standard deviation, they say 4. So sigma gonna be 4. Now, z-score, we're gonna find it. We need x value. So here is the measured speeds of 3 cars traveling along this stretch of a highway. As first x value is 62, second is 47, third is 56. Now, z-score is calculated based on mu and sigma. Mu is 56, sigma gonna be 4. Now, we need x value, so x gonna be 62, first one right here. Then you're gonna find the z-score. 62 minus 56 over 4. That's gonna be 1.5. That's the z-score for x equals 62. Next x value gonna be 42. That's the second car. Z-score gonna be 47 minus 56 over 4. That's gonna be negative 2.25. Third one, 56. That's third car speed. 56, z gonna be 56 minus 56 over 4. That's gonna be 0. That's how to calculate the z-score. Then we're gonna find how gonna use z-score in the next one. So z-score that corresponds to each speed is calculated below. So how gonna interpret the z-score? X is 62, z equal 1.5. X is 47, z-score negative 2.25. X is 56 equals 0. So first one is z value is positive, which meaning is 62 miles per hour is 1.5 standard deviation above the mean. This one is less than 0, z-score 2.25. 47 miles per hour is 2.25 standard deviation below the mean because z value is negative. Z-score is 0, meaning is that's exactly mean. That's gonna be 0. So 56 miles per hour is equal to the mean. So we give the user unusual, very unusual score right there, guys. See, 47 miles per hour is unusually slow because that speed corresponds to z-score negative 2.25. That's we're gonna interpret z-score. Another way we're gonna use z-score to compare the two data sets. The table shows mean height and standard deviation for the population of men, population of women. Compare the z-score for the 6 foot tall man and 6 foot tall woman. Here is the table, guys. Mu gonna be 9.9 inches for man height. Standard deviation is 3. Woman's height gonna be 4.3 inches. Standard deviation is 2.6. Let's find each z-score, guys. Very careful. This is inches. This is foot. So inch gonna be changed. Foot gonna be changed into the inch. 6 foot gonna be 72 inches. Let's find the z-score. What is the z-score formula? Z gonna be x minus mu over sigma. So let's find the first one. First z-score for the 6 foot tall man. Z gonna be x minus mu over sigma. X is not plug in the 6, 72 minus mean height for man gonna be 69.9 over standard deviation is 3. That's the Z score is 0.7. But for the woman, let's find the Z score for the 6 foot tall woman. Z gonna be x minus mean over sigma. X is 72. Woman's height, mean woman's height gonna be 64.3. Woman's height standard deviation 2.6. That's gonna be 3.0. What does this Z-square tells us? So here, Z-square for the 6 foot tall man, that's gonna be 0.7. Z-square for the 6 foot tall woman, Z-square is 3. We have this visualization, this diagram here. Z-square 0.7, 0.7 is right there, guys. That meaning is this is among the typical height for the man. That's usual score. But Z-square 3.0, 3.0 is right there. That means this is among the unusual height for the woman. So now you can use the Z-square compared to different data set have interpretation. Let's summarize the key ideas from today's lecture. First one is we learned the measure of a position help us understand where data values fall within a distribution and how much they vary. Then 5 number summary and box plots allow us to clearly see center, spread, and possible outlier in a data set. IQR focus on the middle 50% of data and help us identify unusual values, outlier. Then Z-score tells us how far a value is from the mean in terms of standard deviation, which help us compare values across different data sets.